All right. Thank you, everybody, for coming to the class today. Today we're going to do a demo how to run Agarose gel electrophoresis and how to analyze the DNA that you purified from your mini prep or just any DNA in general. So hang out, make sure you ask questions if you have any questions. I'm here to answer them, and we're going to begin. So the first step of Agarose gel electrophoresis is making the Agarose that you use in your gel. Now, Agarose, though it can be expensive, you know, it is just a regular molecule matrix that you use to separate DNA. Now, you could use other materials, agar and other things, that probably work just as well as Agarose. Agarose is just something that's sold to us by science companies to make us pay lots of money to do science. Bogus. But it's really not that expensive. So usually when you're doing Agarose gel electrophoresis, you're going to run a 1% gel. Now 1% gel is, for us, for most cases, it's 0.5 grams agar for 50 ml TAE buffer. Now, you want to make sure you use TAE buffer in your gel. If you use water, your gel's not going to run correctly and things are going to be messed up. So take 0.5 grams Agarose and mix it with 50 ml TAE buffer, and then heat it in the microwave for about 1 minute. And this is what you get. Hey Kent, what's up? So after we have our molten Agarose solution, the next thing we're going to do is we're going to add a gel green or DNA dye. So the DNA dye is usually about 1 to 10,000. So that's, for us, 5 microliters for 50 mLs. So take your DNA safe gel stain and add 5 microliters. And what should happen is it should turn your Agarose a little bit reddish pink. Now this dye, what it does is it binds to the DNA and allows us to visualize it. The next thing we got to do is pour our gel. And so the way we pour our gel is we take our gel tray and we wrap it in duct tape. I know it sounds crazy, but it works really well. So just take some duct tape or any type of tape, except for maybe Scotch tape. Make sure you make sure that the sides are smoothed down really well, and so no Agarose can leak out. It's nice and stuck on there. And do the other side. Now, believe it or not, this will hold the molten Agarose inside and will allow you to mold an Agarose gel. So I like to push it down on all sides, make sure it's flattened out, make sure it's stuck there nice and tight. Now the one thing I forgot that I'm going to have to run and get is the gel comb. Vincent, the classes are recorded. If you just click on the ODIN YouTube channel and go to videos, you should be able to find all the recorded classes. All the recorded classes. If you missed this class, or missed the previous class, or the next class, just click on the ODIN YouTube channel, and you should be able to watch it. Alright, so the one thing I forgot is the comb. But let me go grab one. I will be right back. Let me see. Do I have me up here? Alright, I'm back with my comb. So you just basically put your comb right on top of the gel like that. Now what the comb does is it makes sure that you form wells. That's where we're going to add the sample. Next what you do is you just dump it in there. If you're next to a fridge, just put it in the fridge. It'll cool down really fast. Since I'm not next to a fridge, I'm just going to put this on a cold pack, and hopefully that should help it cool down. And usually it'll take, I don't know, depending, 10 to 15 minutes for it to cool down. In the meantime, what we will do is we will set up our electrophoresis box. So, how to make a simple gel electrophoresis box. The first thing you need is a Tupperware container, or any container. Any container that can hold your gel, right? So you remember the size of the gel that we had. So, you know, just make a container that can fit your gel. The next thing you need electrodes. Now, generally for gel electrophoresis boxes, you use platinum wire. Platinum can be kind of expensive, but you know, you can use most anything. In this case, we're going to use aluminum. Aluminum works in the future, but aluminum breaks down because it gets electrolyzed. Platinum doesn't. So in the future, you know, it's not a bad idea to get some platinum wire. It is a little bit expensive, but it saves you some effort. And then you need a power source. You can use 9-volt batteries put together in series, or you can eventually get a power supply and use one of those. So I'll show you how to use both. So this is how you set it up. All right. So we got our Tupperware container. Now you want to make 2 different electrodes. Now the way that gel electrophoresis works is that a current is going to run from one end to the other, right? And that current is going to move the DNA along through the gel and then through the gel matrix that we have. So what you want to do is you want to create 2 electrodes just using the tin foil. So what they should do is they should go into the bottom of the Tupperware container, and they should stick out where we can connect alligator clips to them. So it doesn't really matter how you fold these up or what exactly you do or how thick they are. They can be as pretty or as ugly as you want. Basically, you just want them to stick down inside the gel and stick out of the gel a little bit, right? So that's it. Now, the next thing you do is you want to have some batteries that you can connect together. Now, you can run a gel electrophoresis on, you know, as little voltage as you want, or up to about 140, 150 volts. Now, the less voltage you use, the longer it takes. And if you use too much voltage, the current gets too high, the resistance, what's going to happen is it's going to heat up your gel and melt things and stuff like that. So, you know, using 150 volts or less is generally good. Now, what you can do is, if you're using 9-volt batteries, they're cheap if you buy them off of Amazon, you connect them together where the big side connects to the little side, right? And you could do that over and over again, and you could create a series circuit with these 9-volt batteries to where the total voltage is equal to all the voltages of the batteries. This one is not opening up. So with these 4 batteries, what we will have is we will have 36 total volts. Right? Now, the next thing you got to do is you got to connect the battery to the electrodes. Now, when you're running gel electrophoresis, what you want to do is you want to connect, you want the positive side to be where the top of the gel is, and the negative side to be where the bottom of the gel is. All right? Oh, no, did I get that backwards? Yeah, no, the negative side, the black, where the top of the gel is, and the positive side, the red, where the bottom of the gel is. Sorry about that. Now, you can tell what's the positive and negative side on these 9-volt batteries because they're labeled. So the small side is the positive, the big side is the negative, right? So what you can do is take some alligator clips and connect one to the negative side. Let's flip this around. And one to the positive side. And then when we're ready, we can connect them to the electrodes. All right? So the next thing we need, copper wires, you know, I mean, they're probably going to work just as good or worse than aluminum foil. Yeah. I mean, you basically got everything else and then platinum. So, the next thing you're going to need is you're going to need TAE buffer. Now, TAE buffer, what it is it provides electrolytes so that a current can run through our gel box, right? So mix up TAE buffer and make enough so that you can fill up the gel box about the height of the gel, right? So the gel is about, yay big. So you're going to want at least that much filled in here. That's probably about, 100 mLs, maybe more. So dump in tea buffer. That looks like about enough. All right. So let's make sure these electrodes are down in there nice and good. Now, once you connect your electrodes, try not to stick 2 fingers in the solution at one time, because it's going to create a circuit and you're going to get shocked. So, you know, try to keep it to 1 finger, or just not touch anything without gloves. It's a good idea. Let's put on some gloves so we don't shock ourselves. Gloves. That's what they're good for. To stop you from contaminating things and to keep you from shocking yourself. All right. Now we'll connect the negative side. Man, why do I keep messing this up? The negative side goes at the top. And the positive side goes at the bottom. All right. Now, what we should start to see is electrolysis. You should start to see some bubbles forming. You can see tiny bits of bubbles forming on the negative electrode. Don't know how fresh these batteries are, but you should start to see some bubbles forming. Let's see if we can see. Is it possible to zoom in and see bubbles? See how you can see the bubbles starting to form? No bubbles really forming on the positive electrode. Bubbles. Now that's gas being released because of the hydrolysis that's occurring. Now, depending on how much voltage you are running through it, you can see a lot of bubbles streaming off of it. Right now, just a little bit of bubbles. How deep does the gel need to be relative to the comb? So the comb goes in the gel. The gel tray that you have should be fine, but if you're using your own gel tray or making up your own gel tray and comb, it just needs to go in a little bit. Trial and error might be a thing that you're going to have to do, but it just needs to stick in a little bit because you're adding very little amounts of DNA and DNA dye to get this thing to go. So, you know, you probably only need, it probably only needs to go in like, I don't know, 5 millimeters, I don't know. Not that much. Not that much at all. All right. So now we need to set up a few things. So we need our plasmid or plasmids that we purified, right? So if you did a mini prep plasmid purification or have some DNA that you want to quantify or see, that's what you're going to need. So, got my plasmid. Next thing you need is you need a DNA ladder. Right? So, for a plasmid, you're going to want to run a 1 kb DNA ladder. Now, the plasmid is usually going to run higher than the DNA ladder. Even though it might only be, 5, 6, 7,000 in weight. Hold on. So, you're going to use 1 kb DNA ladder. And then you need DNA loading buffer to load stuff on there. Alright. So, we have everything pretty much set up. Now, the way that DNA runs is it'll run from the negative side to the positive side, right? And as it runs through the gel, smaller pieces will move faster, right? Because the smaller pieces, you just imagine smaller pieces can fit through spaces easier. So the smaller pieces move faster because they can move through the gel easier. Bigger pieces have a harder time moving through the gel, right? So bigger pieces move much slower. So what an Agarose gel does, it essentially separates things by weight. It's more size, but in DNA, where size is, where weight's based on size, you're also kind of separating it by weight, right? So big pieces of DNA at the top, small pieces of DNA at the bottom. That's the way it should go. So with a plasmid, plasmids are pretty big, so we should expect them to see them at the top of the gel. All right. See how my gel's doing. Looks like it's almost solidified. Now, what you do with your gel is basically once it's solidified, is you can just pop out the comb. And then take off the duct tape. And once you take off the duct tape, you should be able to slide the gel right out of there. Let's see. Whoop. See? Here's the gel. It's pretty good, nice and solid. Make sure that the comb didn't go all the way through. Now we just place our gel in the liquid and make sure it is submerged. All right. So we have our gel submerged in the liquid. Now the next thing we're going to do is we are going to add our samples and the materials to the gel. So the first thing we're going to do is add ladder. I'd recommend for your first try, in general, just add 5 microliters. If you're having a tough time seeing the ladder, you can add more than 5 microliters, but start out with 5 microliters. Now this is the hard part. Hard part is adding samples to your gel, right? Because what you got to do is you basically have to find out where the well is with just the tip. Feel with the tip, be very gentle. And then once you think you've found the well, squirt the liquid in there. And you can see it filling up the well. Now I suggest, obviously, using 2 hands. One hand to stabilize the other hand as you pipette stuff in there. But it's hard and it takes some getting used to. You just have to, figure it out. learn by doing on this one. Learn by doing. Now, the DNA buffer has a dye mixed with glycerol. The latter already has the dye and glycerol. Now, glycerol, what it does is it's heavier than water, so it'll hold the sample down in the well. Now, because this is a 6X DNA dye, what you want to do is you want to add 1 microliter of dye for every 5 microliters of liquid, right? Generally, there's nothing wrong with doing more. Don't do less. So I usually just always use 3 microliters. It's easy to work with. So take 3 microliters of dye and pipette it on some parafilm, just like that. So you got a little droplet of dye on the parafilm, right? It should sit there nice and good. Now you're going to want to take 10 microliters of your plasmid that you purified, and you're going to want to mix it with the dye on the parafilm. So you take your pipette, put it down, and just slowly pipette up and down, mixing the dye with your DNA and the parafilm. Now, it's going to take two attempts to put the whole liquid in there, right? So take a little bit, bring it over, use your finger to stabilize, feel the well with the tip very gently. You can see the gel move slightly. Come back, take the rest, and add the rest of the gel. And there you go. So now you have your plasmid and DNA sample. Now, even though glycerol helps keep stuff in the gel, it'll start to diffuse out, so you don't want to take too long. The DNA ladder, if you leave it for too long, you'll start to lose some of it. So now the next thing we're going to do is just connect up our electrophoresis, and we're going to watch the dye start to move. So this is going to take a little while. What I'm going to do is I'm going to use a normal electrophoresis power supply to kind of speed this up a little bit, so we get this moving a little faster. Generally, you can find these on eBay or other places. They probably cost somewhere around $60 or so. So what we're going to do is we're going to connect the negative to the negative, the positive to the positive, and then we'll run it at 120 volts. Now, when you start running at more volts, you see how there's a lot more bubbles? So that's kind of what happens to gas release. Now, what we should start to see is we should start to see the dye move out of the well and start moving down the gel. You can start to see it. See how the dye is starting to move into the gel? So with lower voltage, this is going to take a little longer. There is nothing wrong with waiting. Obviously, you can also just connect more 9-volt batteries. They work and last pretty well. So now this is moving down the gel. So what we're going to do is we are going to wait a little bit. Let's get this down. we are going to wait a little bit and allow this sample to run down the gel, and then we're going to visualize it. We'll visualize it using the blue light. And Mark, I had to load it with 2 uses of the pipette because the pipette only goes up to 10 microliters, and there's more than 10 microliters in the little droplet. So obviously, if you use a bigger pipette, it'll take, you know, just 1 try. But because I was using a 10 microliter pipette, it took me 2 tries. All right. Any other questions while we're waiting on this thing moving? Now, generally, what you want is you want to wait until the dye. So what we're seeing right now is not actually DNA. It's just the dye that we mixed with the sample. So the dye we mixed with the sample is also moving with the current. So what you want to wait is when that dye gets to about halfway down the gel. You can obviously visualize it before that, but that's when you should no, so Mark, in one well, so you want to put each sample in different wells. So in the first well, you can see on the gel, so we have 2 different wells. And the first well is the ladder. That's 5 microliters ladder. And the second well is the sample. And that's just 10 microliters plasmid, 3 microliters dye. You can use less dye. As a general rule, I don't like to use less than 3 microliters. It just helps prevent pipetting errors and other things like that. So I just use a minimum of 3 microliters no matter how much I'm pipetting. You can't really use too much dye, loading dye. But you can definitely use too little. So I like to err on the side of just always using, you know, too much. Just in case I mess up, make errors with my pipette and stuff like that. So yeah, the ladder is just a cut up piece of DNA. So let's see if I go. So you can find this on our website, and it's also in the classroom. So here is the 1 kb DNA ladder. So it's DNA that's cut up, and we have different sizes. So these sizes give us kind of something we can measure our DNA against, right? And the cool thing is that the 4,000 base pair band actually is concentrated at 100 nanograms per 5 microliters, right? So we can actually estimate the concentration of our DNA by comparing it to the brightness of that 4,000 microliter band. So the 4th band up. All right. We've run our gel a little bit. So let's try and visualize it. So with our kits, we give you some orangish film that you can put in front of your camera, and we give you blue lights. The blue lights aren't that strong. We need to upgrade. What I would recommend is buying a blue light flashlight off of Amazon, something like this, Joylight. I know they make one. Oof. And, you know, this Ultra Fire 8HB3 blue light, it works great. You might, if you don't buy these brands, have to purchase a few to test it out. Now what you do is you look through you look from behind the orange gel. So the orange gel should be in front of your eyes, and you shine the blue light below the orange gel. And look, you can see the DNA band pretty bright right there. And you can kind of see the ladder. It's a little bit of a smear because it hasn't separated really well yet. But you can see that DNA band pretty bright right there, right? I can see, obviously, you can see this stuff a lot better in person. But your DNA should look like a greenish, smeary thing. A greenish band, just like that, right? That should be what the DNA. If you don't see anything there, that means that the DNA is, you didn't purify any DNA, or you didn't purify a high enough concentration to visualize. Now the other thing to note is that you could kind of tell, it's hard to see here, the plasmid DNA band is higher than the ladder. And that's what you want. So if your DNA band is lower than the ladder, that's not a good sign. You probably just purified some junk DNA or something like that. It's not good. If your DNA should be higher than the ladder, or, you know, at the proper size in the ladder. So you have to remember that the ladder is made of linear pieces of DNA, and our plasmid is circular. Now circular, like a globule, a ball, is going to have a harder time moving around than a linear piece of DNA, because a linear piece of DNA can fit through stuff better, so it can just move through things. So this circular plasmid, it sometimes runs higher, but if the plasmid is cut or has a nick or something like that, that can normally happen during purification, or normally happens just, you know, in some process, then it might run a little bit lower, but it should never run below the ladder. If it's running all the way below the ladder, it's a bad sign. Very bad sign. Just throw out your sample, start over. The DNA is probably not that good. So, now generally what you want to do is you want to keep running this out a little bit longer. So you want to see the ladder extend out. So you run it out longer, and you know, wait until the ladder extends a little bit so you can see individual bands in the ladder, and then you can analyze the DNA properly. If you're lazy like me, you can just run it for a few minutes or whatever. Run it until you can see the plasmid band, make sure it's above the ladder, and you're all good. But don't be lazy like me. Don't be lazy like me. All right, Tom asks, I had the dye migrate out of the gel to the negative side. What might cause that? Nothing, unless you just have the voltages reversed. The dye should never migrate the opposite way, because it runs right from the negative side to the positive side. So the only thing that could possibly be it was you had the current voltage reversed in some way. That's all I can imagine. Sorry, Tom. All right. So purify your plasmids, grow up your bacteria, purify your plasmids using mini prep, and then run it out on a gel. After you run it out on a gel, what you're going to do is you're going to submit it for DNA sequencing. Now, let me see. Are we doing that this week or next week in the class? Let's see. Classwork this week. Analyzing agarose gel. Next week we're going to submit DNA sequencing, but if you want to get ahead, if you're crushing it and you got some nice plasmid and you want to send out for DNA sequence, you can go ahead. If you're in the U.S., I would recommend what happened to the bacterial chromosomal DNA. The bacterial chromosomal DNA, it has lots of proteins and other stuff on it, so it gets precipitated and chopped up. It never makes it to really attach to the column. Now, sometimes some of it will attach to the column, and if you really try hard to get DNA off the column, you'll get just a bunch of small pieces of DNA that are probably chromosomal in nature. But during the mini prep process, usually the DNA will be harshly treated, so it'll be chopped up and precipitated out with all the proteins that are attached to it. So just the plasmid DNA will be left. Now this is just, obviously there's going to be other things in it, maybe even RNA and stuff like that, but we're talking like generalizations here. Obviously this isn't the most, we're not getting the highest purity DNA, but it's pretty pure. It's pretty good. For such a simple procedure like a mini prep, it's pretty good. Yeah. All right. So, any other questions? Any other questions this week about agarose gel electrophoresis or your mini prep or growing up your bacteria? Has everybody had that, done that pretty okay? You gonna do it? All right. I guess I'm probably just boring everybody. A good concentration is if you see it. If you see anything, it's generally a good concentration. You know, you should expect something around, you know, I don't know, 20 to 100 nanograms per microliter. So, but if you see something, you're good. Why were we culturing the bacteria to get plasmid DNA? Is it just more of it? Since you ordered it online, couldn't they just provide more so that we could skip the mini prep? Yes, we could provide DNA so you could skip the mini prep, but the whole point of this class is to learn how to do mini preps. Because you're going to use it sometime if you're doing molecular biology and genetic engineering. You're going to have to do mini preps. So learning to do mini preps is an integral part of this class of everything. So we could have just purified the DNA and sent it to you, or you can pay somebody else to purify DNA for you. But you know, learning how to do mini preps is pretty good. It's something you should know. Like, yeah, mini preps aren't going anywhere anytime soon. They're going to be around for a while. Anything else? Genetics class is new. This is the first time we're running it. So yes. You don't have to run the DNA out of it, actually, Tom. So what you do, after you have run your gel, Just take a container, a bottle, if you want to use a Ziploc bag, whatever you want, and just break up your gel and put it in there. Now, remember, like, if you heat up your gel again, it's going to melt the agarose, and the DNA is just going to be distributed all throughout the agarose. And so, when it's distributed throughout the agarose, you can't see it anymore because it's just so little of it in the whole thing. So it works just fine. So you only want to reuse gels maybe about 3 times at most, and you want to add a little bit of DNA gel stain to the gel every time you reheat it, because some of it gets electrolyzed, some of it gets run out of the gel. So add a few more microliters every time you reheat it. But it's probably good for about 3 runs, and it should be just fine. So yeah, just stick it in there. It should stay just fine. I've had gels last at room temperature for a month, just sitting there. Stick it in the fridge if you want. Probably last really long. So yeah, you can totally reuse the gels. All right. Yeah, so the point of running a gel is to basically just to confirm, deny you have any plasmid. Obviously, if you trust your plasmid purification skills, you could just send it off for sequencing. But it's going to cost you $6 or $8 plus shipping. So you might as well take the 30 minutes or whatever and just run out in a gel. Don't waste your time, don't waste your money. But you could also just send it out for sequencing and, let sequencing tell you if you have anything there. Yeah. Yeah, I mean, it's just... Yeah, Joe, it is possible to retrieve DNA from the gel. If you're retrieving DNA from the gel, don't use a reused gel because obviously there's other DNA in it. But basically what you do is you just cut out the band of DNA from the gel, and then there's procedures, there's kits that you can find online that allow you to retrieve the DNA from a gel. Generally, you probably won't have to do this too much, so I wouldn't worry too much about it, but it is possible. Mark, you can use it to identify DNA in certain cases if you use restriction enzymes to digest the plasmid. So what you can do, and what we'll probably see later in the class, is if you add a restriction enzyme and mix it with plasmid, and if the restriction enzyme cuts the plasmid and creates bands of a certain size, you can actually use it to identify the plasmid based on the size of the bands you see in the gel. So when combined with restriction enzymes, you can actually, kind of use it to identify DNA. All right. Anything else? Otherwise, as always, ask your questions in the Google Classroom. It's great. If you have any questions or having any issues, ask them there. We'll help you out. It also helps out the other students if you ask questions there, because other people probably have same or similar questions, right? So ask your questions in the classroom. It really helps everybody out. If you need anything, email us. Sorry, Mark, that you haven't got your package yet and it's stuck at customs. Keep updated on it, and if it doesn't arrive soon, let us know. But otherwise, hope everybody has a good day. Talk to you soon. See you next Tuesday. Well, that was weird.